Hello, hello. This is Tsvwg. Please come in. Please take a seat. We're going to be talking about transport area activities for this working group. We need a JavaScribe. Oh, excellent. Yes, please log in. Thank you. And we need a note taker, please. We have one. Can we have a second if possible? Thanks very much, Teresa. We should do this. If we can have a second one just to help, that would be good. Having one unblocks it, but having two is nice. It's a wonderful opportunity. We will try and reward you in some way. Okay, that wasn't a very good promise, was it? Okay, we'll start the working group in just a minute. Press this button here afterwards, yeah?
Hang on.
Oh, how do we go by? Yeah, okay.
That's not it.
Press this button first. Yeah.
Go take it off the screen. No, that's done.
That's good.
Now
so
what needs?
One more button.
Yeah. I know. I need to hit. Well, that one's got the.
No?
Yeah, no, it wants to be that way. It wants to be that way.
Okay.
Now the question is, where is page? Which one of these is page down? Oops.
Right.
Bingo.
Whoa.
All right.
That's another reward.
Different user interface. Thank you.
Okay. Okay, so we've got technical support for running a PowerPoint. We have a note taker, JavaScribe, and two chairs. Are we ready?
No, we're going to do this anyway.
Okay. Right. We don't have slides from Bob. Bob, we don't have slides from you. You do? We don't. David, can you find?
Hang on.
Yeah, we're trying to track multiple things.
No, I do not have recent slides. I do not have recent slides from Bob. Maybe they might just you.
That's possible.
The URL. I don't do it.
No, well, that's newfangled email, isn't it? Bob. Slides for this? Yes. I have slides. I'll upload them.
Good.
David will have to work out how to get them, but we could get through the first part of the agenda without that.
Okay.
Okay, we start.
Indeed we do.
Hi, I'm Gary Fairhurst. I'm the first of these people listed on this slide. The second working group chair is Where's Eddie? Where's Eddie is in a different continent and will be joining us remotely as best he can. And this is?
And I'm David Black, third person listed on this slide. Together we're ringmasters of this three-ring circus, better known as Tsvwg. Welcome. Okay, this is the standard IETF note. Well, by participating in this meeting, whether in person or remotely, this applies to you. Okay, we've taken care of a note taker and a scribe. We'll be asking for our reviewers for drafts as we go along. There's a whole bunch of things Tsvwg works on, so we're always looking for people to take a look at drafts. In general, if you have a new draft that is intended for Tsvwg, please ensure that Tsvwg turns up in the draft name in the usual position so that we know where to, we know to have a look.
A note to the JavaScribe, if Magnus says anything, please make sure we get it quickly. Thank you.
Okay. All right. Following from the previous slide, document quality relies on reviews. Please review documents here in this working group and at least one other working group. In general, the IETF runs on reviews and review feedback. So if you would like documents you care about to be reviewed, please review other documents, and we will all benefit. All right. Time for accomplishments of status. I'm afraid Tsvwg, like a number of internet transports, is bursty. This is not one of those bursty times. There have been no RFCs published since Montreal. Oops, it should be 3 internet drafts in AUTH 48. We'll fix that and repost these slides. This is what happens when you prepare chair slides based on a combination of jet lag and caffeine. In any case, the FEC framework drafts are in Auth 48. They're actively being discussed. We've seen email within the past day or so on these. So those are the 3 drafts. They go together. There'll be RFCs sometime very soon.
Vincent believes that's done, so I think we'll just see them very soon.
Yeah, I mean, I think all the views are done. The changes are done. It's just a matter of double checking them and rounding up the sign-offs from all the authors. We have one draft in the RFC editor queue that has been there for a long time, but there's been development. This is the DiffServ and WebRTC QoS draft, which for many IETFs was in misref state. It is now only in ref state because the missing reference apparently has shown up, and the infamous WebRTC cluster 238 is likely to get published sometime in the near future, including this draft. We have no IDs at IESG. There are 3 IDs with working group chairs and authors after working group last call, and just to prove that the world's not fair, all 3 of them are mine as the responsible working group chair. I've talked to Bob Briscoe, who's the author of the first 2 drafts on ECN and CAP. We know at a minimum what the text is that's needed in these drafts on fragmentation interaction. We know how to write the text to be minimally compatible with 3168. Bob thinks he'd like to do better. Expect to see before the next IETF some better text, and we will review the text on the mailing list before we move these drafts forward for publication. The other one is a transport header confidentiality impacts. This draft was working group last called, was actually called across 3 areas. We cross-posted to both inter-area and security folks. And let's just simply say an interesting time was had by all. Draft is being revised. The major goal of the revision is for the draft to take a more or less neutral stance on transport protocol header encryption. The posted -09 version is already heading in that direction. More to come. Stay tuned. There will probably be a second working group last call on this draft before the next IETF. Okay.
Hi, Gori Fares, just as a document editor for that draft. We believe that we have material now that we can use to make a new revision shortly after this IETF, and we've spoken to several of the people who contributed comments to get new text. Yeah. So I think this will go ahead.
Yeah, and I'm cautiously here comes the other co-author.
Hi, Colin Perkins. I'm the other author of that draft. Yeah, just to be clear, I mean, you say to be revised to have a neutral point of view. That was always the intent, and we clearly missed, but that's what we were aiming for.
Yeah, and I'm speaking for myself as the responsible chair. Yes, I've understood that's always been the intent. Not quite realized the first time around. The next version to be posted will be considerably better in that regard, and we'll run a second last call on it.
Hi, Tommy Pauly, Apple. So just to the point of this, I spoke a bit to the authors, but also I noted in your email about wanting to be neutral. Just want to kind of clarify what we mean by neutral here, because I think we don't want to necessarily set it up as an opposition between should we encrypt headers or not, but it's really where do we draw the boundaries and what are the consequences of it. So maybe even just phrasing is let's be objective about when you make this choice, this is the effect. And it's not saying we are necessarily being neutral between being pro and anti, because I think for a lot of the community, as we are looking into Quick, there is definitely a pro to doing this encryption. We just need to understand the consequences of it.
Right, and this draft is primarily aimed at describing the design consequences of encrypting transport headers, mostly from a within the network point of view. so that it's something to be considered in doing the design. It's not supposed to be advocating in one direction or the other, but rather providing design considerations so that an intelligent, considered choice can be made.
Right. Yeah, I guess I would just encourage that as we are reworking out the tone of the text, that we shouldn't necessarily shy away from saying there are positive reasons and good things that we get from this encryption that benefit the development of transfer protocols, and being honestly enthusiastic about that as we are also pointing out the qualifications.
Can I just sure, Tommy? Was that a offer to have a quick look at the text? We believe will do that.
Yes. So if we have early versions, I would be happy to review anything.
Yes, and Colin Perkins, I mean, to be clear, I think we are not. We're certainly not saying don't do encryption. We're big fans of encryption. Yep. We just realize that there are other things. That there are sometimes reasons to consider doing other things.
Absolutely.
Yeah.
I think we all agree on it. It's just like, how do we communicate outside of this community where we do understand what we're saying, the right tone, such that they don't misunderstand us.
Sure.
Hi, Brian Trammell, sort of the same comment, slightly different angle of it. As somebody who's been, involved in this discussion in this forum for a little while, spent some time on it. I think that this document is going to need much more wordsmithing than maybe other documents that come out of TSVWG in the past, simply because a lot of people are being kind of, I don't want to say emotional about it, but there is a lot of people who are picking things apart and maybe not assuming best intentions here. So I will also offer to go through the language of this document with a fine-tooth comb and find ways where maybe there are opportunities for misinterpretation that can be.
Will you be available in the next couple of weeks to do that? Offline.
Yeah. Let's talk offline. But I can make that happen next week. Yes.
Okay. Good. All right. So with luck, that draft will be moving forward. Okay, we have no IDs in working group last call. No draft from last call. We're likely to start working group last call on 2 drafts soon, STTP NATs and Datagram Datagram MT Discovery. That's Datagram PLPMTUD is the long acronym. We spelled out a few pieces of it. As for the L4S drafts, we will discuss the next steps for the L4S drafts on Thursday, not today. We have enough fun today. Thank you. Okay, there are 7 additional working group drafts listed here in various stages. I relisted the L4S drafts here just because I could. I'm not going to read off the whole list. Bunch of related drafts. Over in 6-man, there's a PMTUD draft for V6. In int area, there is an individual draft right now from Ron Bonica on lossless PMTUD, which also includes a new ICMP message. There's an L4S and diffserv draft that's been around for a while. Not much happening on it lately. Loops. There will be a side meeting on loops tomorrow morning, 8:30 a.m., focused on scope and encapsulation details. I've listed the main loops draft. If you put loops into the data tracker and search for drafts, you'll find that there's 2 more. All 3 are part of that meeting tomorrow morning. Transfer-related drafts, a whole bunch of them. The SFC continues to work on ECN for NSH. The reason this one's interesting is not so much for ECM, which is stuff we work on, but because it's related to the tunnel congestion feedback draft that is a working group draft. There is the low latency DOCSIS draft that's been submitted to the independent submission editor and likely to be published via that route. 2 SCE-related queuing drafts that aren't directly on the agenda, but are related to stuff that will be discussed on Thursday. There will be an exploratory side meeting tomorrow morning, again, this on VIP-A on RDMA congestion control, which will include at least the following 3 drafts listed there. Unfortunately, ICCRG ran out of time, so the 3rd draft down there was not talked about all in ICCRG this morning. We have a draft later today on exposed bits. Here's an exposed lost bits draft that was presented last time around. The interior tunnels draft continues to move forward in the interior working group along with the fragmentation fragility draft. And there's a SOX protocol revision in progress. That draft may or may not be coming to this working group. I'm not sure. A couple of SCTP drafts in addition to what you'll see here. There's a multipath draft, and then there's a draft on retransmission details. There have been a couple of contributions to 3GPP, one on L4S and one that was more general. Those of you familiar with 3GPP have fun with this. Follow up. Okay. TSVWG agenda. So we're about to see, this is a summary of the agenda. We've done documents, accomplishments, and status, about to do milestone review, and then there'll be a bunch of drafts. Friday, a bunch more drafts. Gee, wasn't that interesting? Okay, milestone review. First 2 February 2019 milestones are for the easy encapsulation drafts. Those have been delayed. Bob, do you think we can get those done for January, or is that too out? Okay, Bob thinks we can get them done January. I made a good guess. L4S drafts. We'll pick that back up again on Thursday. I don't care to try to can't really figure out when they're going to be ready to be submitted until we have the discussion on Thursday. SCTP NAT support obviously didn't happen in July. February sound reasonable?
To what? Yes, because the plan is to start that soon, as you'll discover.
Yes. Okay. The PLPMTUD draft and transfer header confidentiality drafts. These I'm hoping will get done earlier, but for the time being, we're going to shove the dates out to April of next year to allow for another IETF meeting cycle. The SCTP BIS draft, shove out 2 meeting cycles of September, and the next 2 dates, April for tunnel congestion feedback and UDP transport options. We'll deal with these at the next meeting. In addition, I'm going to pencil in a June 2020 time frame for the NQB draft for now. After the NQB is discussed, we might have a better idea today. All right. Finally, we get to the agenda so we can bash it. Items 1 and 2, we've pretty much already done, document status, etc. Agenda, we're in the middle of agenda bashing, and the SOX update we basically gave, which is that the SOX draft may move to this working group. For the
moment, it still bears interior name. So if you're a transport person interested in SOX, please comment on that list. So please use the list to keep that draft progressing.
Okay. Rest of the day, we're going to have a co-development hackathon update covering TCP Prague, L4S, and SCE as one set of topics. In addition, there's been some work on datagram PLPMTUD for SCTP. 3 SCTP drafts, and then the datagram PLPMTUD draft. Whoops. Should hit the right. There we go. And then we're gonna finish today with 3 new work drafts. NQB, which is the DiffServ PHP for non-queue building traffic. That's the draft we adopted at the last meeting. There's going to be a presentation on DCCP multipath that complements the presentation in ICCRG this morning. And we'll have a final draft on endpoint congestion control guidelines. Shifting to Thursday. We're going to start with yet another round of the UDP options draft, and then a session on L4S, both an update in the drafts and discussion of the issues in the tracker. The two principal SCE drafts, mostly focused on the first one, but we put both on the agenda here because these two need to be understood together to understand how SCE, all the pieces of SCE work together. And then end of the agenda on Thursday, where we have another round of the QCI and DiffServ draft. We have what's the spin and delay bits, which is this is the alternative. This is one of the drafts in the alternative approaches to transport header encryption, which is go ahead and encrypt the headers and then selectively expose some limited information that might be useful in the clear in the network. And then a presentation that follows on from prior presentation, I think about a year ago, on a inbound resource reservation protocol. This is how to apply that to DiffServ, and they have some results. Okay, I believe that's it. Any comments or revisions desired on the agenda? All right, consider the agenda bashed. And next up, we need to go do a hackathon. Let's see if we can go find the slides here. Hang on.
So the first one will be Bob, and we'll also have a remote participant for the PLP MTU. So yeah, we need to work out how to do this. You need to open a new window somehow. Yeah. And press update, press refresh. Double there. There. And then it just appears. Excellent. You can start talking, Bob. It won't count against your time.
Am I meant to stand on this cross?
You can do, yeah, if you can. Yeah.
Right. Okay, I was asked to split out the update on TCP Prague to this session and have L4S more generally on Thursday. So have you found it yet?
There we go.
Okay, so the acknowledgement list here is too long to put on the first slide because it's like now a large number of companies and people and everything. So next, right, a quick recap. The motivation for TCP Prague and Prague congestion controls generally, and the L4S architecture even more generally, is ultra-low queuing delay. And the next slide will say what that means for all internet applications, including capacity-seeking ones. And the rest of the L4S architecture is about transition mechanisms to that, such as the dual QA/QM and per-flow queuing. And the trick for doing ultra-low queuing delay, this is just a very brief recap, is to have much smaller saw teeth so that you can have both low queuing delay and high utilization, as shown in that picture there. But that creates a lot more congestion events, so that's why you have to have the transitions next. Sorry, slightly off the top there. Ultra-low queuing delay is of the order of 1 millisecond, and with 99th percentile around 1 millisecond, and here we show 5/9 percentile still at 8 milliseconds compared to others under a very heavy traffic load. This is a copy slide.
Just in time IT, the left and right arrows should do what you expect, and the good news is the whole slide is displaying on the screen as the audience. It's just being cut off for you for your convenience.
Right. Okay. So this slide gives the sort of structure of the rest of the talk. It's all about the requirements on the right that are in the draft ECN L4S ID at the bottom left there, and they are for congestion controls that are called scalable, and what you have to do in order to be able to send an L4S packet with the L4S identifier, which is ECT1, and they're derived from a meeting that actually was held in 2015 in Prague, which is why all these protocols have the name Prague in them, where a bunch of people got together and set those those requirements down. They've remained pretty much the same as they've gone into internet drafts. And they're not just for TCP, but I'm going to talk just about the TCP reference implementation mostly in this talk. And that's that slide. So I'm going to use them as you see on the left as I go down them, which I didn't go down them in the previous slide. This is a copy of a slide from July. And I'm going to sort of give you a delta on the next slide to show colors changing. So watch now, right? Go back, watch now, right? Okay. If you weren't watching, I'm not going to do it again. You'll see essentially we've been focusing on the yellow and orange bits and red bits that are now all green. But they're only light green, the three in the middle, which the legend is along the top. And that means the research has been done and it's open. So, this is meant to be the IETF. It's not meant to be research, but TCP Prague is more in the research end of things. So this is why this is just a status update. I'm now going to go through a number of those rows. The first one was already green, but it's now about to be upstreamed. That's what Ilpo, who's just been contracted in to work on that, to upstream into the Linux mainline. At the hackathon, he structured the whole thing into a sequence set of patches so that we can start to do that, or prepare at least for upstreaming to the Linux stack, which is just a quick thank you to Ilpo. He started work on this on Saturday at the hackathon, having defended his PhD on Thursday, and sort of got a job now on this. So he was both getting his head around the code and starting to work on it. Right. Then, by the way, his PhD wasn't on this subject, but it was related. The next one, which was the one that was completely red before in the table and is now green, or light green at least. To the big issue number 16 in the issues list of whether there are any classic ECM bottlenecks, and if there are, how does TCP Prague fall back to Reno-friendly behavior? So we're focused on a solution to this problem, but there is also the question of prevalence of the problem, the two subheadings on the slide. We're focused on the solution because it has been pointed out that even if the problem's not prevalent, it could, the standards are there, so someone could deploy something later. Personally, I think it's unlikely after 19 years, so, but let's move on. So I published a discussion paper on a design to do this with pseudocode in it, analysis, rationale, and Assad, who's also just been hired in to work on this, has now implemented it and started testing work on it. And I've asked him if he can also make his code available so that other people can test it once he feels it's stable enough, which should be today, maybe. He was working on that at the hackathon as well. Well, he'd written the code a couple of weeks ago, but he's been working on setting up evaluations of it. The question of the prevalence of the problem, going back to this slide in the inset from Apple, they found 30% of devices in Argentina were seeing CE. Doesn't necessarily mean it's single queue causing that, but we did dig into that based on a clue from Apple, and got in touch with the ISP, and they found they were doing overwriting the TOS byte with zeros, with hex 17 or something, which was causing the CE to, which is why that was a problem. And we're still not sure whether that's whether any of the other is single queue 3168. In the new BBRv2 code, there's an L4S CCN side to that. There is RTT dependence, which is one of the other rows in the table. And we've been testing various combinations of that against various congestion controls and AQMs during the hackathon. And more testing and then possibly design iteration is needed. Scaling down to a fractional window was one of the ones in there, and I'm going to talk about that Thursday morning. That's been done. It's got it working. It's in the Linux, not in the Linux kernel. It's been coded into. It's currently research code. So there'll be a session Thursday morning before the next TSVG that will include something on that. And here's the slide that says what those sessions are. So before the TSVWG meeting on Thursday, which is at 9:45, we've got a side meeting in the same room at 8:30 to go over TCP Prague status update. And I've posted to the TSV list and other lists, ICCRG, TCPM, the coordinates to get there, and the agenda or provisional agenda. And then we'll also continue talking about L4S in the second slot, as David pointed out. And there's all the links to all that is on the URL at the end.
I want Aaron's quacker.
Done? Yeah, but you can't use it because I'd finished.
Okay. Thanks, Mark.
Thanks.
How do you take control of this?
Oh, alrighty.
How do you get out of
Okay.
Oh, so the next should be remote.
Hang on a minute here.
So we should have a remote presentation. Do we have Julius online?
Whoops. That wasn't what I wanted.
How do we bring Julius online? Do we press the red button?
Hang on. That was bizarre. I'm going to try forward there.
Yeah, but Julius should be remote on the Techo.
Hang on a minute.
Just press that, or do we
I'll
have
press
to?
that, see if it works.
Gotcha.
All right. Which slide deck am I searching for here?
So, can we bring the remote participant online to do their update on coding for PLPM to UD? If we not, then we come back to that because we should be a remote presentation.
All right. Okay. I know that the SCE folks were participating in a hackathon. Does anyone from the SCE team want to give us an interesting update on what's happened so far? Jonathan, sure.
I didn't prepare any slides specifically for this, but hopefully that's okay.
Real-time update is probably a feature.
Well, I think there were two main things that we achieved at the hackathon. One of them was some work on interoperability with ACK-ECN, just to make sure that when an SCE endpoint and an ACK-ECN supporting endpoint talk to each other, that something sensible happens. And I think we were able to achieve something useful with that with the help of Richard Jeffenegger. The other interesting thing we did was some investigation on what happens when you have a bursty link and variations in latency on the short timescales. And we found that these can have quite a big effect on high fidelity congestion control in general due to a very short effective queue depth when used with a red type or a threshold type marking scheme. But we also had some success with trying out a new marking scheme for the SCE feedback based on the CODEL algorithm. So we have a new version of AQM that's actually using two instances of CODEL, one for CE marking and one for SCE marking, with just slightly different parameters. And that proved to give quite a considerably better throughput in the bursty environment, and it still seemed to perform well in the ordinary environment. There's still more work to be done on evaluating how well that works and tuning the parameters, but it looks very promising.
Okay, thank you.
All right. Right, we'll take the next thing in line.
Which is,
What is it?
did you open them all up there? I have no idea what's up there.
It should be Michael's stuff.
This one. This? Yeah, it should be that one.
Yeah.
All righty. Okay.
So, hi, I'm Michael Tuxon, or not as the case may be, but I'm pretty close to Michael. This is the update on the SCTP-based draft. The plan is to publish a BIS to RSC 4960, and I shall iterate again that this is intending to revise the spec to make it clearer, implement the errata which we've identified, and then the intention will be to sound out the possibility of progressing this to full standard. So this is an important document in this respect, and it becomes easier to read each time it's edited. Document history is, well, we're in the process at the moment of going past editorial fixes to the cleanup of musts and shoulds. The original document was written with lowercase must meaning must and uppercase must meaning must, but we're going to go through and just check that that is actually correct, because the IETF's got a little bit more pedantic on this, and I think this is a good thing to do to make sure that the shoulds and musts are called out correctly. So that's what they're currently doing. Work in progress, handling of multiple remote addresses in the associate primitive, and there is a draft of the text to go in GitHub. There's some more editorial issues to be done, maybe some layout improvements. And the good news is, if I put my chair hat on now, is that usually once one SCTP piece of work is done, they quickly move on to the next piece. And this is the next piece of work to be completed. And they expect to complete this before Vancouver. Okay. Anybody got any questions on the BIS draft? We already have offers to review, but it's becoming increasingly interesting to find good reviewers for this document, or any reviewers, in fact, to get feedback on how good that document is evolving as we head towards the inevitable end of trying to publish it. Thank you. Is that an end for me with a nice ping? Let's see the next one. Okay. NAT support. Aha. In this case, I'm tunneling.
And we figured out how to use the Chromebook.
Oh, that's clever. Michael Tuxon again. Although I have no different sets of co-authors. Michael's co-authors are Randall and Irene. And this is a document that's been with our working group for far too long. In fact, it's been with us so long that it came from another working group called Behave, which closed a long, long time ago. It's about adding that NAT support to SCTP. IPv4 NAT support was missing in SCTP. It's the last of our IETF transports that doesn't actually have a spec defining it, and this document tries to do that. The status is we're currently at draft 15. There were comments from a person called Goria Fairhurst on draft 14, going through this, trying to separate out mainly what it means to implement SCTP NAT support as somebody building a box versus somebody doing an SCTP implementation. This draft covers both. We have comments from Maxim, and these comments have been addressed. We believe this document is ready for working group last call, as in the authors believe this, and the chairs are willing to believe this, but there's one extra thing that's cropped up. So before we take that working group last call discussion, we should have a look at the Yang model for this.
Hang on. What the? It's that one. All right. Not sure what I did there. Keep my fingers off the keyboard. Oh, let's see if we can find it. Let's see if we can find a Yang slide here. That datagram. What the? I don't know what happened here. Let's see. All right. Hang on. We'll go get it off of this. You're looking for. Yes, we have Yang slides. Here we go. And that should do it. Okay.
Am I presenting these as well?
Yeah, I think so. This is part of the NAT draft. It's
Okay.
or proposed part of the NAT draft.
So I'm going to go through these, and heads up, please, if you look at these slides, do you think we should add a Yang model to the NAT draft? After we've gone through these slides, I'd like to take questions about the Yang model or any interest in this. And then finally, we're going to ask if we can complete a consensus call on whether the document is ready for working group last call publication. But first of all, let's look at the NAT document with Yang. We could add some NAT-related considerations, including the Yang model, to this document. This is within the scope of what we're allowed to do. How much effort would be involved? There are a couple of things that we have to do. We have to describe the int tag, v tag, the x v tag, and this doesn't sound hugely difficult. We could express this in Yang. And the module might look something like this. The person who wrote these slide decks say this is straightforward. And here I confess, I do not know whether this is straightforward or not straightforward. So we are looking for some expertise in this working group who would understand the Yang model, or somebody to volunteer to read this. As chairs, that would be really helpful. We do have Yang MIB doctors equivalent. I mean, so we can get expert advice on this, but we need working group advice on this first. Should we go ahead with the model that looks like this and integrate this into the NAT support document? And the suggestion by the person who volunteered this slide deck is it's easy just to add this to the Yang model, and that's better than creating a separate model to describe something which is kind of like only this long. Any objections, any thoughts? Anybody able to understand what this is? Anyone wish to come to the mic?
I'll admit to understanding some of this. The most important statement on the screen is just short of halfway down, where the magic word is augment, which means as opposed to describing a new model, Yang has this very nice ability to just go add a few things that perhaps should have been put in the first time but weren't. Mm-hmm. And so this really is all the Yang, and it's blissfully short.
Can anybody come to the mic and say something? Sorry for looking at you through the corner of my eye.
Jake Holland. I've done a little bit with Yang, but I'm less familiar with SCTP. What are the V tags int and ext? I'm not sure the.
What are the V tags?
Sorry?
The V tag or the.
Yeah, there's two leaves here, the int V tag and the ext V tag, and is there some meaning for this besides internal verification tag? I don't know.
It's how SCTP demuxes flows. So it's tied in with the NAT state. But I think if anybody is willing to just say, hey, I don't understand a couple of lines of this, it would be useful to talk to to Michael and the person who proposed it to see whether kind of at least we're heading in a direction that's useful. We can close this without doing this, or we can add this.
I guess I have no strong opinion. If you're asking for does the yang look sane at all, I have no objection if there's some understanding of what these things mean, minus various nits like the space or whatever, right? But the reason I'm not volunteering is because I don't know what we're doing with this.
Yeah.
So hi, Brian Trammell. Let me rephrase the question, Jake, before you sit all the way down. I think the question is the description internal verification tag and external verification tag enough for somebody who understands SCTP enough to be messing with the NAT state on an SCTP NAT box to understand what that means? And I think so. Just because if you're managing, right, like, so this is the additional state that you need because of the way that FlowMux and DMux works in SCTP. I had actually forgotten that this was called a VTAG until just now. It's like VTAG. Oh yeah, that's the thing, right? Yeah. So I think it's fine. Do we want to just put it in this document as opposed to another document? Yeah, sure. Yes. Seems perfectly reasonable. Thanks. Is this Yang sane other than the VTAG thing? I have no idea. I don't read Yang.
That's okay. We have SCTP experts. We can get Yang experts. I'm asking the working group. Please talk.
Bernard Bomarkson. Is there an assumption that somehow writing these drafts will actually make SCTP work with NATs?
Right, but with the NATs that wish to do this, there
aren't any.
Well, there are some. Yeah. Right. There are working SCTP NATs out there that do this. They are maybe not in people's home boxes. This is fine.
It's like saying they're magic rabbits. I mean, yeah, maybe.
Assuming there are magic rabbits, we would like to configure them with Yang because this is the IETF. So
exactly. Yeah, this isn't the thing up for debate. We want to get this thing out of this working group. Right. Have we bashed this? Do we know what we're doing, David?
It sounds like it's moving forward.
Sounds
like we've got a few people we can quick check with to make sure the SCTP contents are okay, and it looks like they probably are. And after that, a trip to the Yang doctors, one of whom will be very, very happy to get something this short to look at, and we might have something useful.
Okay. So my final question this time with the chair hat on is the SCTP NAT draft ready for publication, meta solving whether we include this? Is there anybody here who thinks there is additional work that needs to be done to finish that draft?
All right. I think seeing no hands raised in the room, I think we're just going to go ahead and move forward. We should get this one done and check it off. Okay. I'm going to try to get Nagesh's slides up. Let's see if we can do that. All right, I don't see Nagesh's slides up. Hang on, let's see. Yeah, all right. Oops, it gives me what I wanted, and then takes it right off the screen. Oh well, isn't the website wonderful? No, we don't seem to have gotten slides from Nagesh. Let's see. Is he? Yes, he is online. What happens if I push the red button? We'll give that a shot. I push the red button and nothing happens. What a useful red button.
So if MeTecho is monitoring this, the chairs are completely lost about how to make any of the remote presentations happen. Okay, and we will come back to them when we can. Well,
the red button. You push the red
Jake
button.
is
The red button.
Jabber Scribe. MeTecho is. Are you guys on Jabber?
It
Sure.
says the remote presenter needs to unmute himself. I wonder which one we've got. Okay.
Hello?
Yes. Hello, we got somebody.
Yeah, it's me, Julius. So,
Yeah. Okay. The gain on your mic is the gain on your mic is set too high. You're clipping very badly. Now, this is Julius is the presenter for which one of these drafts?
Back to this one.
Okay. Back to the SCTP deal. Okay. Go ahead. This is going to be 3.2. We're going back to. Let me go get that up.
is it better now?
Yes, that's much better. Thank you.
All right, great.
All right, give me a minute. We'll get the slides set up in the room. And okay, go ahead. With luck, you can advance your own slides. If not, ask us and we'll move them.
Thank you. Okay, so this is a short overview over the work we've been doing for the last couple of weeks on the implementation of the DPLP MTUD algorithm for SCTP. Oh no, it's the wrong slide, isn't it?
Yeah, that's the wrong
Sorry.
All right. Sorry. I thought that was the right ones. Hang on here.
Because I'm not going fast.
No, nice.
All right. Okay, so should be that one, right?
Yes.
Okay. And that's what I get.
Still not the right ones.
Yeah, it looks like we've got the wrong set of slides associated with the meeting materials. Yeah. Hang on, we're looking for your slides.
All right.
Okay. If you can plug an HDMI into yours, that might be the fastest way to get it projected as opposed to this high-tech stuff. We're resorting to a hardware solution. Just a minute. I'm pretty sure that's going to be an HDMI connector. Yeah, no, I don't have a. All right, we're going to upload the slides and hope it happens quickly. Upload a vision. Okay, now, if that's worked correctly, we hit reload to there. Okay, we might have managed to move the bits into the right place. All right, and That looks better.
Yes, yeah, it looks better.
Okay, sorry about that.
No problem at all.
Okay, and okay, there we go. Right person's name underlined this time.
Yes, great. Thank you so much. Okay, so as I said, this is a short review of the work I've been doing for the last couple of weeks on the implementation of DPLP MTUD for SCTP. Next slide, please. So as a short recap, this is an overview of the state machine of the DPLP MTUD algorithm in the current -09 draft version. And as a short reminder, so the DPLP MTUD algorithm deals with finding the right MTU of a path. So the packetization layer knows how big to make the packet it sends. Next slide, please. And so what we have done is, or what we're doing is, we are implementing this for SCTP for a code base that is shared between the FreeBSD kernel and a user-space SCTP implementation called user SCTP. And the user-space implementation is used in most WebRTC implementations, including Firefox and Chrome. It supports SCTP over IPv4 and IPv6, and also SCTP over UDP and DTLS. But currently, our focus is on IPv4 and IPv6. We haven't tested the UDP and DTLS part yet. Next slide, please. So where we started is about 1.5 years ago or so, Irene Rüngeler did the first initial implementation of DPLP MTUD for SCTP. And basically all of the standardization work that has been done so far is based on her implementation. Her work is very early on this, so it hasn't been upstreamed. And next slide, please. What we do basically is we take her changes from back then and merge this to a current version of the FreeBSD kernel, and we're getting it working there. And so what we also do is we then update her work to the latest -09 draft version, and we're still checking updates to the draft. And along the way, we have fixed some bugs. Next slide, please. So these are some considerations for implementers who want to implement the algorithm for their own transport protocols or own transport implementations. So we've seen that the semantics of MTU changes are different for PLP MTUD, because in PMTUD, the MTU of a path can only shrink, while in PLP MTUD it can also grow. This might make some things slightly different, or changes the semantics of some functions a bit. And also you should note that the probes in DPLP MTUD are congestion controlled and not rate controlled. So they should not trigger a congestion control response when they are lost. And also one thing we're currently seeing in our implementation is that if we see an MTU change, the frequency with which we see RTT updates decreases. But this is most likely just an implementation bug we still have to figure out. Next slide, please. So this also links me to what we still have to do. It's on the one side, figure out what is going wrong with this bug. And also we still have to fix some variable names to be fully draft compliant. And also we still have the test with IPv6 on the agenda, because we only have tested with IPv4 so far. And we have to make sure that everything works well with all platforms that are supported by user SCTP. And we're also thinking about a way to do automated MTU testing in order to facilitate tests for DTLS and UDP. Okay, thank you.
Okay, thank you very much. I think we're going to quickly bash the agenda and go straight from here to the main datagram PLPMTUD draft to try to avoid inducing too much whiplash. We'll pick up the third SCTP draft after this. Now let's see if we can get the slides up that we came up last time. Yeah, that would be these, wouldn't it?
Okay, right. I am Gori Fairhurst, being Gori Fairhurst as an editor of this document. This is Datagram Packetization Layer Path MTU Discovery. It should be a presentation of 09. That's the document that we as editors have. I'm an idiot. I don't know how to make XML to RFC work with Rev3, so I couldn't post it. Sorry, didn't know how to put the SVG files in. So there's something just a little bit coming along in a moment. But DPLP MTUD version 8, which has been out in the working group for a while, is a complete document. Next slide. There's the magic bit. We moved to XML v3 with SVG diagrams because our AD thought it was an interesting experiment for us. Thanks, AD. This is testing the ID submission process because it doesn't work, for me anyway. If you looked at 08, we started the experiment there, and the table of contents is rendered as 2 lines for each line, so it all looks terrible. That's not our fault. There's a good HTML somewhere if you follow the link here. If you're not in HTML land, everything's okay. The diagrams are okay, the ASCII art's okay, and it hasn't changed a lot. So let's talk about what the diagram looks like. The core diagram looks like this. This was redrawn again in 08 without changing the spec to make this clear, we hope, and simple, we hope, because actually the core of this mechanism is quite simple. Basically, you enable PLP-MTUD by moving out of the disabled state by knowing you have connectivity and doing an initial probe. You then reach a base MTU. You check that works. You then try and search to increase your MTU, sending a number of probes. Each time a probe succeeds, you increase the path MTU. If the probe succeeds and then subsequently fails for a larger size, you carry for a certain number of attempts to send other probe packets. These probe packets may be the same size, larger, which would be foolish, or smaller, which might be smart. But there you send a certain number of probes. If you don't get response to anything bigger than the last one that worked, you give up. The original version of the algorithm suggested a value of 10 for the number of probes you send after you've found a new value and then one that failed. We think that a value of 3 is probably more conservative as a recommended number. The document does not define this search algorithm. My personal opinion is any algorithm's probably okay, except for the stupid one of trying to increase by 1 byte every packet, which I hope no one is even so stupid as to try and think would be useful. Jumping to large sizes is probably very smart because in the internet as a whole, people have deployed infrastructure which has certain limits or use certain tunnels, so you can more or less guess good values to increase to. If all things go wrong, you return to the base and you start from a bottom path MTU, which you know should work, and you try and increase again. If really it's seriously wrong because the base doesn't work, you move to error. The document does not define what you do in error. It makes suggestions. You could try and keep the link open. You maybe could try enabling fragmentation in v4. You could try other stuff, but this is below what you said should work. If you were care to implement error as just give up, that's also allowed. So error is kind of this unknown state where you could be really smart, apply lots of heuristics, but we don't really say. The simple algorithm is quite simple. Periodically, when everything's working normally, you'll be in a search complete state, and after a period of time, which is minutes, you go back to the searching state and send a probe message to continue your search. If you are totally clueless about what your transport is doing, like you're a tunnel, or maybe just a UDP-based transport with no connection state, so you don't know what's going on, at that point, you should also check that the current path is supporting the current path MTU that you've discovered. All of this is written in the spec. What's changed recently? We added this connectivity section that has to precede everything to each packetization layer in the description. This made it slightly more modular to describe a new packetization layer. We added text that we thought was obvious, but we thought we should really add, which is you have to tell the PathMTU cache in your host, in your node, in your equipment, to not use the cache value when you're sending a probe, and also to not use that cache when it receives packet to big messages for your path. I can never do that. Because if you let PMTUD control what's going on, you get the wrong result. So you have to tell the network layer to disable this for this particular flow. Julius, who we saw online, has been implementing this in SCTP and has been telling us where he found things which were rather confusing. Fortunately, this was mainly text, and we fixed this in 0.8 and some final fixes in 0.9. This relates to a number of documents, which is why I'm going to motivate in a moment that we should working group last call the next version. It's an update to 4821, which was mainly focused on TCP. This focuses not on TCP. It focuses on things that aren't TCP. Interior Fragile is a document aiming at BCP, now in RFC Editor Q, which says you should do this when you can in your protocol to enable us to work without requiring fragmentation in the network layer. Therefore, this other document is held up waiting for us to complete our work here. The quick transport is not held up because it's not yet ready for publication. It will be ready soon, guys. Yeah, and it refers to this, so we should do it for quick transport. UDP options is our own working group item here that also defines it, and there's a draft that Tom and I have co-authored which defines the little pieces that go with UDP options to add that to UDP options in the future when your UDP options is finished. And of course, SCTP is implementing this at least in one user space and kernel implementation, and hopefully SCTP will follow this for other implementations. SCTP defined something like this from the beginning. It just didn't have the details which are in this particular spec. So several documents refer to this or will refer to this very soon. We have some implementations, just because I know David's going to have to write this up. In the future, if we go for a last call, there's FreeBSD, there's some FreeBSD work with UDP options, and there's partial implementations with Quick, and we'd be keen to work with other people to try and make more quick implementations do this. Please talk to us. And there's been 3 custom implementations along the pathway to get here, none of which have been upstreamed. We had early reviews from Lars. Thank you, Lars, wherever you are. He spotted some shoulds that should have been musts and musts that should have been shoulds and all the good things that we should do. So we will fix these in version 9. They're in the editor queue once we learn to use XML to RSC revision 3. We will publish those. And I think from the author's point of view, we've had our initial review. Other people are referring to this, and we think the work's done. So we'd like to suggest this is ready for a working group last call.
All right. Think of that as a Christmas present. Don't know whether it's going to be early or late, though. Are the SCTP chairs here? What kind of sorry, not SCTP. Are the quick chairs here? And somebody who knows what schedule the quick transport draft is likely to be on?
Somebody must be brave enough to talk to that one.
No, we can go talk. Okay, we got somebody. Yay!
It's an easy, quick question.
Martin Duke. We had a talk about this at our interim in Cupertino. There's a hope of working group last call soon-ish, which I'd say maybe Vancouver, maybe even earlier. But there's a strong expectation that will not be the real working group last call. that in fact there will be a lot of comments and that will require some rework, inevitably. So yes. So we anticipate. Yeah, it's a better way to say it. Thank you, Brian. So there's going to be more than one working group last call, almost certainly. However, the first one is probably in the next quarter or so going to happen.
Okay. That's helpful because I don't think we're quite as optimistic about the UDP options draft, which is why the UDP options material for DLPMP You know, whatever that acronym is, I'll get it right one of these times. Why the UDP options work for datagram PathMQ discovery has been separated into a separate draft. That way we can last call this one and publish it without having it wait for the main UDP options draft. There's a separate draft that covers the use of UDP options for this purpose, and presumably this all then gets referenced from the SCTP BIS draft.
Yeah, and I suspect the text for quick is going to be the correct text for quick, because the stuff in this document is fairly generic in transport, and I think it's stable, but this is why we would like to coordinate the working group last call with quick. The details of that are in quick itself, because that's where it belongs. So I hope there's no real dependency either way, but we want to align these two to make sure that they really are published together.
Martin Duke again. Yeah, I have trouble believing that anything will change at this point is going to have any impact on MTUD at all.
Yeah. Thank you. That was useful. Okay, David. That's it. Do you want to ask any other questions to the working group, or can I sit down?
I think you can sit down. We will probably expect a working group last call on this draft in the near future.
Do you want to get some reviewers? Or I'll ask, does anybody wish to review this and could raise their hand, because it would help us with the process? Yeah. Martin. Oh, yeah. Ian Sweat as well.
Sorry.
If they'd see one another, they might not have both volunteered, but they did. Anybody else wish to review this? Of course, this will be a review where we're looking for comments from anybody in the working group. We think this is a useful thing to do. Please read it. It's we accept comments on saying on any part of the document, even the readability. So please read the document. Thank you.
Okay, so I'm going to note Martin Duke and Ian Sweat as having volunteered to review. So we'll get at least 2 work group last call reviews. Thank you very much to both of you. Okay, now let's see. We're going to have to go. Hang on. Push that button. Go back here. All right. So I don't believe we have slides for this next item, which I'm going to put up the piece of the agenda. This is 4.4. Apparently. Let's see. Nagesh, if you're online, we're going to push the red button, and maybe you can say a little bit about the 4895 BIS draft. Anybody out there? Yeah. Okay, sorry. Let me push the red button one more time just in case. Anybody out there? All right, we will try to pick this up on Thursday, and maybe we'll have slides there. And also, Nagesh, let me quickly apologize. It looks like a spell checker got your last name. That will be fixed. Okay, so next up is NQB. Yeah? Well, it says he should enter the queue. Oh, yeah. All right. Problem is I can't see the queue on my screen here on the screen here for some reason. All right, let's get the NQB slides up here. Which one of these tabs? Which one did we put it in? Hang on. Yeah. There it is. Those. All right. Wait a minute. Right on cue. All right. Okay, Nagesh, we will pick you up after Greg is done speaking to NQB since we've gone to all the work to get his slides up.
All right. Sorry, Nagesh. Thank you. Greg White and Cable Labs presenting update on the NQB PHP draft on behalf of also my co-author, Thomas Vasadi from ARM. Next slide. Sort of small font, but this is a slide an update of a slide I presented last time. The goal of the NQB PHP is to enable low latency and low loss for sparse traffic flows. And the idea is to define a code point that describes verifiable behavior. So it's not a value judgment. It's not saying that these flows are higher priority than bulk data flows or actually have low latency or low loss sensitivities to latency or loss. It's really just about the behavior of the application. Is it sparse? Is it able to coexist with other sparse flows and not cause latency when it does so? So the idea is that there is no incentive to mismark packets, both due to the fact that it's again not indicating the desire for prioritization, and that it is intended to be verifiable behavior that the network can examine and act on if it sees behavior that's inconsistent with the label of non-queue building. So the applicability of this, the main driving use case really is in the L4S scenario where you have two queues, one for the L4S flows, congestion control flows that can, as Bob discussed earlier, provide ultra low latency for congestion controlled applications. Identify flows that are not congestion controlled that could coexist with those L4S flows. And then also potentially for links that have the ability to optimize access to the channel for sparse traffic. A couple of examples of use cases there, cable broadband links. So we're intending to support this PHP in what we call low latency DOCSIS in the near future. It's in the spec currently, and products are being built to that spec currently, and expect to see that rolling out around the world in the next year or so. Also, LTE and 5G links. There's my co-author is representing the GSMA side of this and bringing in use cases there, and an interest in supporting this PHP as well on LTE and 5G links. In terms of application use cases, generally sparse flows of any type really could label their packets as NQB. The main ones that are driving the development of this are the ones that users care about, having low latency and low loss, in particular, and focus more on the residential and end user environments rather than enterprise environments. So gaming, both the traditional multiplayer online games as well as the cloud gaming applications, mainly for the uplink side of that, which is low data rate traffic on the upstream. And also voice over IP and voice chat kind of applications. Next slide. So the status here is I presented the last TSV working group meeting, last IETF, and was adopted after that meeting. Immediately after adoption, one of the chairs requested that some edits be made prior to uploading it as a working group draft. There were 4 items there. I think we can move on. So continuing the status, there were additionally some mailing list comments about the individual draft around the adoption and shortly after the adoption. In particular, a couple of kind of structural comments on the draft that the individual draft wasn't really written like a PHP definition. It was written more as a motivation for a PHP and included a section on comparison to other approaches. Also, there was a comment that the suggested diff-serve code point of 2A would likely get bleached at ISP ingress, and a suggestion for another code point that might survive. The response to that was maybe that's actually a feature and not a bug, and ISPs that have the ability to support the PHP in their network and provide that service to their customers can actively disable bleaching for that code point and and get the benefit. And those that don't have such an ability in their network, maybe it's okay that they bleach it. There's also some concern, some is probably an understatement, concern about the interoperability with Wi-Fi, both on the enterprise side and residential. I've got a slide later on that gets into that. So finally, in terms of status, uploaded the initial working group draft just at the deadline for this meeting, included those 4 items that David Black had requested, as well as restructuring the draft to be more in line with PHP draft expectations. Next slide. So in terms of what the PHB is, the requirements that are in the draft are these. And just to start off to say this is not intended to be a guaranteed service. It's not, this is not DetNet. This is providing, and again, focused on residential applications and providing a benefit to these sparse flows, but not scheduling access for them specifically and providing guarantees. There's one must statement and the rest are all shoulds. I think some of these are under debate as to should they be something stronger than a should and should they be a must. And it's up to the working group, I guess, to reach a consensus on that. The must statement is that a node that supports this PHB must queue the NQB traffic separate from the queue building traffic. And then the shoulds that follow that are that the NQB traffic should not be rate limited or rate policed separately from the queue building traffic of equivalent importance, and that term is defined a little bit later on. Next one is we should give equal priority to these 2 classes of traffic, assuming they have equivalent importance. And then the next bullet is almost the same thing, but maybe a little bit more specific. Should provide a scheduler that allows these 2 classes of traffic to share the link in a fair manner and provides an example of a scheduler that could do that. And then finally, we get to the definition of what it means to have equivalent importance. Should treat traffic marked as default, so DSCP 0, as queue building traffic having equivalent importance to the NQB marked traffic. Then should have a buffer for the NQB queue that is significantly smaller than the queue building traffic gets. And finally, should support this mechanism that the draft talks about formerly called queue protection, now called traffic protection. And this gets back to that verifiable application behavior, verifiable traffic behavior, an algorithm that can monitor the flows that are entering that non-queue building queue, verify that they actually are non-queue building, they're not causing queue growth and causing latency. And if they are, redirect them to the classic queue or the queue building queue. We have an example of an algorithm that we're using in low latency DOCSIS that's provided in the draft. The only additional requirement around that is it should be objective and verifiable based on the flow behavior, not on application layer constructs. Is there a question?
David Black speaking from the floor again about the very last bullet here. There's an open should versus must, but I want to make something else clear about that, which is it is possible that the word node in that very last requirement might be able to be removed, because one possibility is to do what DOCSIS has done and to have a function that operates at the node level to evict queue building traffic from the NQB queue to a queue where it can go ahead and build a queue. And the other is that you might be able to bring some form of admission control and edge classifying and filtering to bear on this. The concern is that if you don't have what's called traffic protection over property of the PHB, this starts to look an awful lot like EF.
Okay, I think I agree that may be something that can be made more flexible. Certainly, the node that's supporting the PHB has better visibility into what traffic is causing queuing and likely has higher fidelity. In terms of traffic protection, but it may not be the only place.
Yeah, Bob Briscoe, just wanted to come back on the thing about node. In order to be verifiable, to know whether it's building a queue, it sort of has to be on the node that has the queue. That's sort of the point about verifiability. So it's different to the DivServ architecture where you can have edge traffic protection or policing, because there you're policing against a contract, and we're not talking about a contract here.
I still think that there's some flexibility possible here, and this is more of just a heads up, more adventure to come on that last item.
Okay. Right.
Yeah, please use the list to talk about this, because we only just adopted it, so there's plenty of time to talk about it.
Okay.
You like to continue?
Yep. So what is a non-queue building flow? So I've already mentioned it a couple of times. It's non-congestion control. So it's not seeking the capacity of the link. It's typically application limited, low data rate, sparse flows. By labeling itself as non-queue building, it's claiming that it's not going to cause a queue in the network. So it's expecting to remain below the available capacity in the path. And if it eventually does cause queue buildup, it's going to suffer potentially some consequences for doing that. In the L4S architecture, if queue protection is supported, actually not necessarily specifically to L4S, but in a dual queue device, or a device supporting the PHP that has queue protection or traffic protection, this could result in the mismarked packets getting reclassified into the other queue. So they may see higher latency as a result of that. They may arrive out of order because that decision may be done on a packet-by-packet basis rather than a flow-by-flow basis. In LTE and 5G, I think there's still some discussion within GSMA on how exactly to configure this on those links. I think in some of those configurations, a mismarked flow would see higher loss. In others, it may have the exact same ramifications as were listed above, higher latency potentially and out-of-order delivery. Next slide. All right, subject to Wi-Fi. So this has been quite a bit of discussion on the mailing list about how this works with Wi-Fi. The first point is Wi-Fi can be a bottleneck, and so support for this NQB on Wi-Fi links is highly desirable. Particularly ISPs that are intending to roll this out for their broadband customers want to make sure that the benefits that come from segregating non-queue building traffic on the access network link are not lost when that traffic goes across a Wi-Fi link in the home. So future Wi-Fi equipment could support the NQB PHP requirements as they're written, I believe. But current Wi-Fi equipment does not. And so what can we do? So Wi-Fi 802.11 essentially supports 4 queues, background, best effort, video, and voice. The vast majority of traffic in residential situations uses the best effort access category. The others are lightly used or nearly unused. So this must queue separately requirement seems like it's sort of possible. There are at least multiple queues to choose from. But by default, they're statistically prioritized. So voice is the highest priority over video, over best effort, over background. So the should requirement of giving equal priority is a little bit harder to implement on existing Wi-Fi equipment. Some options that have been discussed. One of them is to use one of the other access categories. So you get the queuing separate from the best effort traffic. And configure the channel access parameters, the EDCA parameters for that access category to match the parameters that are used for best effort. So eliminating the prioritization between whatever access category is chosen and best effort. And that's a configuration that is tested by WFA for all of the Wi-Fi certified equipment. At least all equipment does support that configuration. I think the test case for that configuration probably leaves a bit to be desired in terms of actually verifying that that they do get exactly equal priority. But nonetheless, it is a potential option. More likely useful for a Wi-Fi AP that is deployed by the ISP, where they have control over those EDCA parameters. Probably not quite as useful for an AP that is customer owned and operated, and where the user may not be able to adjust those parameters or understand the need for doing so. Second option is to use the video access category, which again is higher priority than best effort, but do something to make sure that the traffic that is marked as NQB and is using that access category remains sparse, so that best effort traffic is not unduly harmed by the presence of low data rate traffic in the video access category. And then also don't expect traffic protection on these Wi-Fi APs. So yes, you can choose a different access category to put this NQB traffic in, but it's not solely for NQB traffic. Any application could mark its packets and to use the same access category, could be queue building traffic, so nothing's guaranteed. So some caution is needed for using, trying to configure existing Wi-Fi networks to give the benefits of NQB without fundamental changes to the software on those devices. And I guess caution both from the perspective of the operator in maybe managing the traffic that uses a different code point from best effort, and also maybe setting expectations for customers that this is not, the performance of this is not guaranteed. So there's an open question as to what more of the draft should say to ensure that caution is used. There's some text that was quoted from RFC 8325, which talks about interactions of diffserv and WMM or Wi-Fi multimedia. That looks like pretty good text. Maybe we could pull some of that into this draft. And I guess an open question is that sufficient? That leads to the next slide. I see a couple. Is this a clarification?
I just thought it worthwhile to note that I think there is some Wi-Fi equipment that can already meet the NQB requirements without...
Close to the mic, Jonathan.
I thought I was pretty close to it. Okay, Jonathan Morton here. I thought it worthwhile to note that I think there is some Wi-Fi equipment that can already meet the NQB requirements, but without needing to recognize the actual code point. And this is things like AS9K and AS10K and I think MT76. Yeah, okay. When driven through a recent version of Linux, because they implement FQCODL on a per station basis and let's see, airtime fairness and things like that.
Okay. Fair enough.
So cool. It's a useful data point, I think.
Okay.
Andrew McGregor. The Wi-Fi MAC's behavior varies in many other parameters between these queues. So, for example, you would not want to put NQB traffic in the VO queue because that also changes the aggregate building and many other things, and so will demolish the performance of the network if you do so. I think NQB and the Wi-Fi queuing are kind of orthogonal, which seems to indicate that we probably actually want more than one NQB code point, unfortunately, because you're likely to want to distinguish between queue building and not traffic in the VI queue.
Fortunately, this is diffserv, no problem.
Well, yes, exactly. But just saying that there are other characteristics that are different between these. The aggregate building parameters are different. The VO queue can't build aggregates and therefore is much less efficient on the wire, on the medium.
And that's due to configuration, right? The TX op size.
Except that changing that configuration is not meaningful because much hardware can't do it.
Okay. Right.
Yeah.
Okay. We need to move on fairly quickly here if we can. So,
okay. You got 2 more slides.
All right.
So that leads into the diffserv code point recommendation. So again, Wi-Fi is an important factor here. And also keep in mind this is primarily talking about residential Wi-Fi and not enterprise Wi-Fi, where today there is not a lot of usage of the other access categories besides best effort. So by default, residential APs and stations use the IP precedence bits, so the top 3 bits of the code point, district code point, to select the access category. Default tables is given there on the right. Choosing a code point and that maps into one of these access categories could help make things work for at least as well as they can with existing Wi-Fi equipment. There is a feature in 802.11 called QoS map, which allows the AP to define a different mapping of code points into access categories. My understanding is that that is not mandatory for WFA certification, so there's an open question as to whether that's supported on stations or even on APs. I don't have any data on that, but that would be interesting to know if that's an option to affect that mapping on residential Wi-Fi networks. And then there's been some discussion about the safety of putting NQB traffic on a different code point, and what happens if there isn't this traffic protection function and you've got a mismarked flow that's actually bulk traffic that could swamp out. Let's say you put on the video access category that could swamp out best effort traffic. And a couple of points there. So one is on the downlink direction. So from the ISP into the user's home network, the ISP could certainly remark that traffic. They could also perform some other functions potentially to monitor the volume of that traffic and remark it if needed. And then on the upstream side, so uplink traffic from end stations, game consoles and PCs, that option isn't available, right? So we need to pick a code point that works well for those uplink applications. And I think it's not been controversial, at least that I've seen, to recommend a code point that maps to the video access category for uplink traffic. It's really this downlink question of who's ensuring that the traffic remains sparse in the downlink direction coming from the ISP. So the draft currently recommends a code point 2A that is a currently unassigned pool 1 code point that could be assigned for this. It does map to that video access category on residential Wi-Fi. There are a few alternative proposals on the mailing list. One from Sebastian Muller suggesting 2 different code points. 6, I think, for traffic going across interconnects, and 2E for that the ISP would map it to 2E before it goes into the home network, and potentially 2E for upstream traffic as well. I think that was a little bit unclear. 2E actually is already assigned to expedited forwarding, so I'm not sure why that one was chosen over 2A. Value 7 was also mentioned. That's unfortunately a pool 2 different code point, so it's assigned for local use, not for standards action. Right.
Yeah.
And then 1E was also suggested primarily for enterprise environments, enterprise Wi-Fi environments, but that's also already assigned to another use. So yeah, 3.
Yeah, discussion here is going to continue on the list. I'll point out that one of the things that happened on the list is ISP could remark downlink traffic. Looks like the most important defense here. If you don't know what the Wi-Fi is going to do, don't send it stuff it's going to do bad things with. And I owe a note to the list. Greg and I had an interesting discussion this morning that might close out the rest of Sebastian's concerns. So let's. Bob would prefer not to have a discussion here if we can avoid one, because we are into negative time at this point. So you get one quick remark.
Yes, I just wonder whether we ought to be agreeing the requirements for what code point to use rather than just keep
send that note to the list, please. We can have discussion there. Okay, next slide.
Yeah, last slide just lists the open items. These are listed directly in the draft as well. So obviously no time for discussion on those, but that's what the mailing list is for. So
yeah, please take to the mailing list, and maybe at the next one we would like to know reasons why you would choose a good DSCP code point and reasons why you choose a bad one, and then hopefully we home in pretty quickly on the one we want. They must be IETF assigned and not used by something else.
Okay, right, thanks.
Okay, do we have slides from Nagesh? All right, let's go see if we can find them. probably have to hit reload. Watch. Hang on. Yeah, I got to hit reload. Give me a minute. Yeah. Well, I think you may have just dismissed him. I guess you need to rejoin the queue now, and then unmute yourself.
Yeah.
All right. Okay. That was sound join the queue. Now hit the button. And
Hello. Hello, are you there?
okay. All right. Hang on. We'll try this again.
Hello.
Okay. We finally got it.
Good afternoon, all. It's Nagesh here. Today, I want to present the changes which we think should be done for the RFC 4895, and the changes are motivated based on the implementation of RFC 4895 auth RFC to implement the DTLS over SCTP for our products. The first point which I want to mention here is with respect to the auth negotiation procedure. The current RFC doesn't have any section explaining how the negotiation should happen if a particular peer doesn't support it. Though the chunks that's present in the RFCs as upper 2 bits as 10, so the receiver is free to ignore the parameter and go ahead with the normal establish of the association. If our client support the auth and server doesn't support it, then then it gets into a situation where the client is assuming that the connection is in the auth mode, whereas the server isn't. And adding to the problem, if a client adds specifically to include data and SAC chunk to be sent in an authenticated way, then the server would be sending data in a normal mode, and the client keeps dropping this data forever. So eventually the connection would get closed without any meaningful data transfer that happened between the peers. In one of the extension RFCs, a socket API extension as a method for a client to query to check if the auth negotiation is successful. But as per me, the problem is may not all implementation might have implemented this extension. So there is no way for the client to know if that auth has gone through normally. So adding this section in the RFC would eventually clear out all the problems, and both the endpoints, by the time they exchange init and init chunk, would know whether the auth has been negotiated successfully between them. Next slide, please. The second point which I want to mention is with respect to support for the extension parameter. We all know that extension parameter was added in RFC 5061, and auth RFC, which is 4895, was introduced much earlier to that. So the 4895 doesn't ask the support for this extension parameter. And if you see the major implementations like LKCTP and FreeBSD doesn't mandate the client to send this parameter, but whereas LKCTP mandates. So if a client which is connecting to LKCTP server doesn't include this extension parameter, then the LKCTP server will drop that connection and will not let the connection to go through. So this forces the client to include the supported extension parameter even when the client doesn't support RFC 5061. So what I feel is we can add this extension parameter support for RFC 4895, which I feel is a desirable one, and which would probably make most of the interworking smooth without having much of the issues. The next optimization or the next changes which I feel should be added to the 4895 RFC is with respect to the support for HMAC identifier. If we see the request chunk for HMAC identifier mentions that there can be more than one HMAC identifier to be present, but whereas the error response supports only a single HMAC identifier parameter. I agree. The current RFC supports only SHA-1 and SHA-256 as options, but in reality, we have much more than these variants of HMAC which is available. And moreover, SHA-1 is something which is already deprecated, and most of the implementation switches to SHA-256 as default. So I feel that extending the HMAC identifier error cause to include more than one HMAC identifier would probably make it easier to extend the RFC in future whenever we have a use case to include other variants of HMAC other than SHA-1 and SHA-256. Next slide, please. The next point is with respect to handling of the chunks in the chunks parameter, which is invalid or unknown to the receiver. Let's say, for example, the client implements stream reconfig option, which is 6525 RFC, and whereas the server doesn't implement it. And if the client includes this reconfig chunk also as one of the chunks to be sent in an authenticated way, then the server would not be able to understand this reconfig chunk type in the chunks parameter, and the RFC also doesn't explain how to address how the server should handle such kind of chunks when it receives in the chunks parameter. So adding a section in the existing RFC which explains the handling would be something which I feel is required. The next point, it's more of an editorial than issue, is with respect to the support for the random parameter. The section 3.1 of the RFC mentioned that the random parameter can be of n bytes, but whereas in the subsequent section for the procedure clearly mentions that the parameter should be of 32 bytes in the context of the current RFC. So there were a couple of doubts which was raised on the RFC mailing list for the same point, which the people who have read the RFC got into confusion whether it should be a n bytes or a 32 bytes. So adding a section or a statement saying that it should be 32 bytes in the context of this RFC would actually clear all the doubts. Next slide, please. The next point is with respect to the formation of the byte vector. The RFC just says that both the client and the server should concatenate the parameters, random chunks, and the HMAC algorithm to form the byte vector, but it doesn't explain the order of concatenation. So there is there can be a possibility where the server and client concatenates these parameters in a different way. So thus creating in a situation where the shade key might not be the same, the byte vector would not be the same. So adding a section or a statement in the RFC which explains the order of concatenation of these parameters to form the byte vectors would clarify this doubt.
Okay. Thanks very much for the presentation. Sorry for the delay in getting you to present, but we appreciate actually having a presentation. Thank you for preparing this. My first chair comment is some of these additions that you recommend could actually be filed as errata possibly, and I think that the normal procedure is to file an errata and find if there's consensus around the errata for the smaller issues, and particularly obsoleting SHA-1 is obviously something we should do. So,
sure.
So I think you need to work with the original editors if possible, but file errata for the things that can have errata filed against them. Does that seem like a great starting point? And then see what else is on the list, and we can decide what to do next.
Definitely. I agree with your comments.
Thank you. And we would take questions now, but I think we'll take questions on the list because we're short of time. So thanks very much for the presentation.
Yeah, and I think,
thank you.
Right. This is David. I think the deal is file the errata that can be filed, and then work with the other folks in the SCTP community, and we can decide probably in the Vancouver timeframe whether what we want to do is for the things that cannot be dealt with as errata, whether we want to go ahead with a working group 4895 BIS draft.
Sure.
Okay. Now we're down to two. We got 2 items left, and got to figure out which one to do.
Is Mark said to do this on Thursday?
Yeah.
What do you think?
We can do that. Yeah. So
Excellent.
that's what we'll do. We'll do Gory's presentation here, and we will try to find some spare time on Thursday for Marcus's presentation. He was able to get time in ICCRG this morning, which was very helpful for that that group. All right. Okay. Let's see if we can get Gory. Where are you? Okay. All right, that looks good. And
So
now if I hit that.
This is me. I made the slide blue so I remember what I was talking about. Hi, I'm Gory Fairhurst, talking as an individual. This is an individual draft that has previously been presented in TCPM for reasons that might become apparent as we go through it. This draft targets this working group, TSVWG, with guidelines for how to do internet congestion control. And we do have stuff in RFCs that talk about internet congestion control. So I guess the first question is, why do we need guidelines? Well, next slide, please. Or clicker. Both, okay. So the IETF has actually said quite a bit about congestion control over the years, particularly about not causing congestion collapse. And there's a general recommendation in RFC 8085 is to leverage existing congestion control methods. And that was cool when we wrote the original UDP guidelines, and quite cool then. It maybe isn't quite so cool at this moment in time when we're seeing other transport frameworks emerge that actually do have new ways of doing congestion control. So maybe the best advice from the IETF isn't just go and use one of our existing congestion controllers. Please do if you don't know how to design a congestion controller. They're pretty difficult. But if you know how to, what guidance do we have? Well, Jana and I sat down at the quick interim in London and had a little bit of a chat, and we thought, I said bravely, it's probably just about 4 pages of text in recommendations. This isn't too difficult. Do you want to write it down, Jana, or do you want me to? And Jana, being smart, said, oh, you just do that, Gory, and then I'll have a look at it. So I read all the RFCs I could find about congestion control. Maybe I've missed some, so that's always a good call. And the RFC already say a lot of the things we want to say, but it took more than 4 pages. In fact, it took 4 sections, but they're not very big sections. I produced 00, which presented previously. 01 was a slightly more coherent version of this, and then 02 was me fixing the annoying typos in 01. In 03, which is approaching where we are now at, I added more text on starvation because I think that is an important thing that protocols have to avoid when we design a congestion controller. We have to avoid starvation and we have to avoid congestion collapse. And I try to differentiate these. I got feedback from various people, and Colin provided feedback on FEC in particular. And I said, yeah, we should talk a bit about FEC. We pointed to RFC 5783. If you don't know what it is, go look it up. It's an interesting RFC. And then we published 04, which is where we are today. I published by the IETF as an individual. The big thing in this document is section 3, which is principles of congestion control. It comes across as a number of different things that you should understand if you're talking about building a new congestion controller. Understand these things first, and then look at these RFC principles when you design it. And there's stuff here which I hope is non-controversial. There's a diversity of path characteristics in the internet. It's actually much more diverse than you would ever imagine. Flow multiplexing and congestion can be annoying. They are not catastrophic, but they are certainly annoying to users, both the multiplexing aspect in terms of jitter and the congestion in terms of queues. The most important thing, however, is to avoid congestion collapse, starvation, and the variants thereof, which block users from actually creating new flows. So what are the guidelines? Well, there's something on congestion initialization, talking about how you start up. Oi, I wanted to do an animation here. It didn't work. Okay, using path capacity is another thing, and avoiding bursts. Burst mitigation was very controversial. It's been written in RFCs for a while. I think Quick resisted it for a little while, but it's in there now, so everything is all hunky-dory. Transmitting excessive bursts in the network is actually a little bit bad for things, for good reasons. Timers and retransmission have to be handled very carefully because of the diversity of things that go on along paths. Responding to potential congestion and how you respond to ECN is something you must do. How? Well, look at the guidelines. Using more capacity than you're currently using is something that's not as easy as people think. There are good ways to do this and there are bad ways to do this. Slow start was a good way up to a point. Now, let's set an envelope for doing this. Network signals are the solution to everything if you can trust them. And so far, we're struggling to work out how to trust them, but some network signals might add value. There's a trust but verify bit in here as well, which we could probably take forward in the future. And protocol mechanisms require some sort of protection. A new thing to the transport area, but yeah, people might try and do bad things with your congestion controller. So work out what to do when you receive information on path and off path. Trying to be quick. What's the purpose of this document? It's to draw a big red box around these things. Put TCP in it. Everything we say in this document should not limit TCP in any way as currently specified. Put quick in this box. Well, the intention is that quick fits in this box. This box is not narrow and it's not short. It's a big box, and quick, I hope, will fit into this box. If that's controversial, then we should talk about this because that's the intention. And other transports we specify here should fit within this box. The box currently is set by BCP 41, RSC 2914. Work with Sally, if you know Sally Floyd, if you remember her. But that's now quite an old document. This document, if we go forward with it, could change BCP 41 or may even replace it. We have to figure this as we go forward. You can have more than one RFC in the same BCP. Question to the working group. I'm trying to be very quick here. Has anyone read it? Does anybody care? Will anybody help me if I try doing this? Or should I spend my time doing other things? I have plenty of other things. And can we do this in TSVWG? Should I just ask these questions, David?
Let's you get to the mic. I will go ahead and volunteer myself. Once I survive getting the transport header encryption draft done, yes, I'm interested in this, but I we've got to survive that draft first. And I see a bunch of people going to the mic, so let's have at it.
Jana Iyengar, thank you for doing the work on this, Gauri. So I did read the draft as promised. It took me a lot less time to do that than it took you to write it up.
I think that's a compliment. Thank you, Jana.
Of labor for me. But I do want to say that I have very specific comments about the draft itself, which I don't want to spend time now at the mic. And I'll talk to you offline about those.
Yeah, but can I just interrupt at this point? I mean, I want to take questions about whether we should do this work and not on whether the recommendations are correct. Yeah.
Fair enough. I think that the work should be done in part because, as you said, and you didn't quite say it this way, but we've written a lot of text about congestion control guidelines and principles and this, that, and the other, and none of them really have guidelines or principles or anything useful as far as I can see. So when looking into all the text that we've produced, I find it difficult to find real recommendations that I can pull out of them. So I think there's a big gap here, and I think we should provide something in that gap. Precisely how that looks is not, it's still not fully clear to me, but it's something more concrete than 2914, because 2914 just lays out the space of things rather than actually give very precise guidelines. And it should be less, I think it needs to be between that and actually specifying exact behavior. It needs to be somewhere in the middle there. So I think it's very relevant, useful, important to have something like this, especially given the flurry of work in congestion control we are seeing. I will just say one quick point that this should be broad. Your box is talking about specific transports, and I agree with that. The way the text is written in the draft seems to be very aligned with TCP. I almost think that this should be broad enough that new congestion control work that happens anywhere should be able to use this, not just within the IETF. These guidelines should be universal in that sense.
Nothing that Jana said offended me in any way. I like these ideas. And if the last thing was a criticism, it's a criticism because the existing RFCs were written mainly with TCP in mind. Many of the words in there were taken more or less directly from those RFCs, because that's the only starting point I believe we can have. Anyway, next person, please.
Marco Koyo. Have I read this? Really not, but I took a quick look at it and it looks useful. So I care.
Okay.
I hope many people here care of it. And it's true that these principles and what the consensus control should do is also elsewhere than 2914. So it's spread all around. So very careful consideration should be taken to look all of that stuff, but in particular, what else to include. So there are a lot of experimental work, and especially that work should be taken very carefully, or look very carefully what to say about that, because it's still experimental.
Interesting.
Praveen, Microsoft. Yeah, I started reading it. I haven't finished it. I will certainly send a review to the mailing list. Yes, I care, and I think it's really important. So I agree with whatever Jana said. So it should be generic enough to apply to all transports, and I think this is really, really important.
Thank you.
Thanks.
Hi, Bob Briscoe. Yes, it's important. I think having done the first round, it may be worth taking out stuff that isn't really saying anything new, just to focus on the things that are updates, if you like, and things that have changed. For instance, the bursts stuff was something previously we didn't really think about because latency wasn't that, we weren't trying to get it that tight. And as machines have needed to go faster and faster, they've tended to aggregate up and then burst. And so that is something that's new. I think there's some new ideas coming out on fairness. As I mentioned in ICCRG, there's a paper in Hotnets about how to measure it and things like that. So try not to keep just repeating stuff from the past, but focus on the things that may be more controversial.
I think we could probably add a section pretty quickly on what we think is the new stuff and see how that goes. That would be useful. Yeah.
Hi, Yoshi Nishida. I just would like to mention that in TCPM we have RTO consider draft. And then, as far as I can read the draft, there are several overlaps. And then we already have a private chat, but if TSVWG will be the venue of this draft, this working group should decide how to, coexist or merge, or should make some kind of decision to how to treat RTO consider.
Yeah.
That's
Yoshi, which draft? RTO considerations?
Yeah, RTO consideration.
Oh, yeah. Okay, got it.
Yeah. So, right. Okay, I guess I should respond just to touch on RTO considerations. This document was a working group document in TCPM and still is, and I expect is now complete. I will speak at TCPM about this. There is nothing inconsistent between that document and this document. So the overlap is purely restating stuff here that Mark also came to the same conclusion on. I went carefully through that, and the overlap is real overlap. It's not contention in a way. So we have to decide on document process if we decide to do two documents, how we manage that. But I will talk specifically about RTO consider, and yeah, it is something that we should reconcile between working groups. Does that answer the question?
Yeah.
Yeah.
Thank you.
Okay, I think
Can we do it in TSVWG? Can we adopt it?
I think we can do the work in TSVWG. I think an adoption call right now is a little premature. I heard a bunch of people.
Okay.
Heard a bunch of people at the mic who are interested and supportive of working on this draft. Let's plan on some revisions, some reviewing the list, and a likely adoption call in Vancouver.
Yeah,
And if you have
a little bit early to adopt this right now.
Yeah, that's fine. And that's what I expected. I just wanted to make the question because if it caused uproar about the idea of it, then I'm not going to carry on. I hear positive noises, and I'm looking for people to actually talk to in the corridor to try and work out how to make that adoption request a real thing at the next IETF.
And I'll commit to actually working with Gauri on the next revision.
Thank you, John. And could the person who spoke behind you the first time, I'm looking at you sitting next to the mic, could you please get up to the mic and say your name, because I didn't catch it for the minutes?
It's Bob Briscoe.
No. Sorry, the person sitting to your left, Bob. Yeah.
Oh, Marco.
Say your name slowly, please.
Markku Kojo.
Thank you.
Yeah, I just wanted to add an addendum to what I said before. Even if you're pulling out things that have changed, we mustn't imply that the previous advice isn't as important as it used to be. It's still important. You know, the congestion control itself, RTO and things like that are all important. We just don't need to keep saying it more. Yeah, and I particularly, I've been trying to think a bit about Sally Floyd, and she kept on at that, and the fact that she kept on at it is possibly one of the reasons why so many people understand it. And if we stop saying it, there are a lot more, or a lot of people who won't understand it or won't appreciate it. It's strange to have to think about that, and it's only when you something's not happened, you start to get complacent about it, but it doesn't mean to say it won't happen. Yeah.
And Bob, I assume you're planning to work on this in your copious spare time that's not available for all the other drafts, you're working on, right?
I think Bob just volunteered.
Yeah, I think Bob just volunteered. I'm just putting on my chair hat and observing Bob's already got a lot of time that he owes to a number of other drafts in his working group.
I'd say maybe Gauri, I, and Bob can try and find some time this week.
Yes.
To sort of sit down and beat this out a little bit more.
Seriously, I'm doing this as an individual, and I'm only going to continue this if other people talk to me, because I'm happy to do some writing, but this is something that has to be written down together. We have to define this box together.
And with that, I think we're done. Thank you very much. And yeah, we'll bash the agenda to get Marcus's presentation in on the next session. We do appear to have some time, although we also have some items on the agenda that capable of explaining to consume all time available and then some.
Thank you. You got us out of a real fix.
Welcome. Do you think it could work in the beginning of next session?
Oh, well,
15.